binti Mustafa. I'm from School of Physics. I'm a first year student of Geophysics and I'm going to be the presenter of the group.
Hello everyone, I am Cheng Yun Leong, a first year student from School of Physics. I major in Applied Physics. I will be the scriptwriter for this video.
Hi, my name is Aniesa Najwa, binti Amin Arwani. I'm a first year student from School of Physics and currently majoring in Geophysics. I will be the editor for this group.
Today, I will introduce to you what is magnetoresistive sensors, or we can simplify it as MR sensors, and its application in our daily life. First, I will tell you the history of magnetoresistive sensors. Back in 1857, Lord Kelvin first discovered magnetoresistive effect when he noticed the slight change in electrical resistance of a piece of an iron when he placed it in the magnetic field. But it took more than 100 years before a first MR sensors concept was introduced by Hans in 1971. 160 years after the discovery, MR sensors have been used in automobiles that we see on the roads as well as in the hard disks. So, what is MR sensors? MR sensor is a type of magnetic sensors that works based on the magnetoresistive effect. Unlike any other sensors, the magnetic sensors do not measure physical quantities such as temperature, pressure, and strain, but they detect the disturbances on the changes in the magnetic field that have been modified or created to obtain this information. MR sensors is work based on magnetoresistive effect. But what is magnetoresistive effect? So if we put an iron in a magnetic field, we will observe that the resistance of that iron may have a slight difference compared to before. The material exhibit this property is called ferromagnetic material. The change in the resistance depends on the angle between the current direction and magnetization. But magnetization can be influenced by the external magnetic field. The resistance of the ferromagnetic material will be the highest if the magnetic force is parallel to current flow, while smallest as magnetic field is 90 degrees to the current flow. So that is how magnetoresistive effect works. Let my left hand be the MR sensors, pen on my right hand having the magnetic field, which the tip or the pen point out the direction of the magnetic force. So as pen approaches to the left hand, the electrical resistance will change. And this situation makes us able to detect what angle the external magnetic field is positioned in the relation to the center. The magnetization of the field also makes it possible to determine the distance between them. So why we use MR sensors? The advantages that MR sensors has is it is robust and able to work in the extreme conditions. For example, for Mars rover Spirit to operate profoundly on Mars, sensors must be able to work in a wide temperature range, which is -100 degrees Celsius, that can turn carbon dioxide into ice to +85 degrees Celsius. It can also withstand the solar and cosmic radiation that can easily damage the semiconductor sensors. But MR sensors use ferromagnetic materials. And the last one is they can withstand mechanical shock. Besides that, it has a wide range of application. For example, the speedometer that detects by rotation of transmission gear, an accelerometer that detects by means of deflection of metal spring in automobile. MR sensors that use magnetometer are able to detect the magnetic north in the compass that we downloaded in most phones nowadays. Meanwhile, in mapping, magnetometer also works with the accelerometer and GPS chip to determine the location and direction. In data storage, MR sensors are also used in the read head of hard disk drive that enables the head to determine the polarity of the magnetic data, which is 0 and 1 in the disk. The disadvantages of these sensors is the temperature drift. The temperature will also affect the resistance of the material, but it can be avoided or minimized by using Wheatstone bridge. For normal conditions, the MR sensors are unable to detect the low magnetic field strength, which will limit MR sensors to be used in the high magnetic field strength only. The modification of bubble hole on it will help to increase in the sensitivity. However, it will make the designs of the MR sensors being complicated to set up. MR sensors having a lot of advantages and wide range of applications such as in automobiles industry, 3C devices, and so on. This invention has led to promising results and will therefore be continued. It is the end of our video. I hope you guys gain some knowledge and insight from our video. And that's all from me. Thank you and bye!